Hello YouTube, in this video we will be building out our very own solar car at home, and this is the final result. Now this project took a lot of dedication and a lot of problem solving, so I really encourage you to watch this video to the very end, and hopefully you enjoy this build. So getting to the first step of the process is that we have a aluminum tubular frame which we designed on SolidWorks. Now it's a great idea to design it on SolidWorks because you can stress test it in the program as well, and this is what I came up with. Now the second step ended up being 3D printing this model to get a better idea of what's going on, where every beam goes here. This way, if any design changes are needed, you can catch on to them before you move on to welding the actual frame. Now right here what we have is the first portion of the frame is welded. There's actually three portions to it. So the first portion is just this piece right here. The second portion will be the roll cage, and the third one is obviously the back. The back is where the motor will be. Now getting to the suspension components of the car, here we have a box of ATV suspension parts, and I will be retrofitting these parts to work on this solar car. Unfortunately, I can't design everything from scratch. That will actually take a lot longer, and it will also be a lot more expensive. So this car is actually being built for a university project, so the budget is limited, and to save time we're able to use a lot more pre-made parts. For example, this is a wheel bearing, and it also has holes right here to hold the brake disc. So the braking, the wheel bearings, the suspension, the strut assembly, all of these you can just grab on from this ATV kit and get it hooked up on here for our purpose. And this kit also came with a pretty decent steering wheel. These parts are obviously very heavy and not intended to be used for a lightweight solar car. Right now the plan is just to get the car running and have a working prototype before there's optimization done on each component, but that will come later on. So mounting the control arm is actually kind of tricky to this because we have to make sure about of a couple of things. First off, that the strut assembly can connect properly, and secondly, the tie rod. This tie rod, as it turns, because you turn the steering wheel, this rod is what will turn, and we have to make sure that this doesn't interfere with the frame, it doesn't touch the frame, so that's important. Now, to make sure that we're able to mount the control arm itself to the frame, I came up with these L brackets. Just cut these off of aluminum. So one goes here, another one goes here. So here we are, guys. The lower control arm is mounted for both sides, and as you can see, it looks pretty solid. However, I did run into an issue, which is that once the spindle goes on and I mount the upper control arm, the upper control arm is actually way too small. Even when you stretch it all the way, it does not reach the frame itself. Now, I am on a deadline for this project, and this frame has to be done soon, so what I decided is actually to cut this control arm and extend it. The choice is either extend the control arm or modify the frame. Modifying the frame I don't really want to do because this frame was designed to handle... we did a lot of stress testing on this frame, and I don't want to tamper with the frame. I would rather tamper with the control arms. So here we are back with the extended control arms. As you can see, they're a lot longer now and almost as long as the lower control arm. So now they have the right length to be attached to the car correctly. And in order to extend these control arms, I actually ended up using the frame tube off this bike. So this used to be a perfectly good bike, but we ended up chopping up the frame right here to make room for to get some metal for the control arms. So that way a perfectly good bike had to sacrifice itself for the sake of the solar car, which is not bad at all. The next step is now to install the steering system. For that, we have this little rack and pinion, and the idea was to maybe weld a metal beam here or another aluminum beam here, and then attach this rack and pinion to the beam with using U-joints or something, or maybe welding it on. But I ran in a little issue. So this is the original tie rod that the kit came with. It's fairly small, so I ended up ordering extensions, and this is the extension right here. So the extension, the length of the extension is actually perfect. This should work. The only issue is that the thread of this rod is not the right size. It was supposed to be in metrics, but it's not. So it doesn't screw on to the existing kit. So now to get around this issue, I'll be using this tap and die kit and threading out the ends of the rod using this bit I picked out. This is just footage of me drilling into the tie rods. I decided to leave this footage on because honestly, it looks really aesthetic. We're drilling into the aluminum beams to create a bracket for the motor. So we're just test fitting this hole to make sure it fits. This is an odd way we came up with to stress test the motor bracket. We're just mimicking forces where the motor goes around with a turn, gets tilting forces on it, and goes up and down. So the plastic sheets that will hold the solar panels are all cut up, and now we move on to building the lid that will house the solar panels. So about this lid, I've realized that the plastic sheets I cut to put on top of the aluminum actually end right about here. So there's not a lot of, I guess, space for us to tie the plastic sheet to these aluminum bars, because I was planning on drilling inside. And for stability too, I just don't think this lid is enough. So what I'll be doing is I'll be putting in more bars here, right about here to here, and another one here to here. That should give it more stability. I have one piece of the aluminum cut out, so I can use that for demonstration. It lines up with this one almost, and it should go right around here. Actually, let's see if I can do this on camera. Push it inwards, and there we go. Fits like a glove. Actually, not totally here. There we go. Fits like a glove. Fits really nicely. So one piece here, and we'll do the same thing there. Weld away right after. So guys, as we saw in the 3D model, we have some curved hues at the top, and that is what we're trying to do here. Get the same shape. Using this tube bender. It's actually a pretty handy tool.
Are you ready?
Yeah, let's lower it. Let's see the result of this tube. Okay, this is hold off on it. That's good, just in case.
No, it needs to be more.
It needs to be more, okay. So this tool doesn't necessarily tell us exactly which angle we're on. So the trick is we remove the metal rod every time and then use one of these.
I'm just curious for all the viewers out here, how does this machine exactly work?
Oh, this is a pretty basic principle. So we have a hydraulic jack in the middle, which works a lot like your jack or car jack, and then we have rollers at the top here, 2 rollers, and the jack pushes up against these rollers. So the jack pushes up the pipe against these 2 rollers, and that's how we bend it. It does it really slowly, so which is kind of nice. Doesn't leave a kink or anything of that nature on the pipe. The only bad thing is you can't see what angle you're on. It's the only bad part. If you video here, you can see the jack go up slowly. You might have to, so you guys might be able to see this jack portion. It goes up slowly.
I mean, we can see it's bending because of this thing right there.
I love how quiet this tool is. Everything involving the build of this car has been incredibly loud, bothers the neighbors, so you can't work at night. You have to be done around 6 o'clock. But this is something that's super quiet and efficient. So I like this.
Great.
I like this tool. So we're continuing with the roll cage process, and as you guys saw in the older video, we bent this tube and this tube to the right size, and now it's actually all welded up. Now I ended up welding the roll cage on top of these L-shaped beams. This way, this is a separate piece. So the roll cage is actually a separate piece. The main reason being is if we ever want to transport this the solar car, we can remove the back part of the frame holding the motor, and then we can easily also dismantle the roll cage piece. Alright guys, so today has been a lot of progress. I ended up putting in the door hinges, as I showed you in the old video, on both the front lid and the back lid. And now, look at that, the back lid opens nice and easily. And I also made a little holder for the hinges. So this way, this is where the rear two solar panels will sit. And I like how it has a little bit of a springing action. So as it comes down, I'm gonna have locking pins that hold this lid in place. Now, similar idea at the front. We have the hinges in here as well. Just regular door hinges getting the job done for us. And look at this. This is actually a giant piece. Almost touches the garage door. And comes down just like that. I'll probably be making in more holders for it so it doesn't open this wide. But this way, let's say we have the wiring and batteries up here, we can easily access everything. So now closing the hinge, or closing this door, we come down here. And again, it has a bit of a springing action. The nice thing is I'll be installing two tabs here, or welding these tabs on. So once it comes down, we can just push in a pin. I'll drill a hole here, and then you can easily just push in a sliding pin, and then the lid stays in its place. And now for one of the final steps, the programming of the motor has finally been finished. The motor needs to be programmed because it has Hall sensors in them. The Hall sensors tell the controller the position of the magnets inside the motor, so that way it can run it. And I'll have these wires extended out to the pedal itself, and as we turn this pedal, the motor should move after I've turned on the switch. Switch is turned on, and now we can see how the motor reacts. So the pedal right here. It actually makes a really cool sound. As you guys can see behind me, the car is actually sitting on top of a trailer right now. The main reason I did this is because I had 3 friends over, and this was my only opportunity to get the car lifted on top of the trailer, because you can't really get on this small utility trailer with ramps. The trailer is actually too small for the car, so as you can tell, both the front wheels, they stick out, and also the rear wheel, this sticks out as well. Now, as I was making progress, I got this plastic sheet mounted on top of this aluminum frame. However, we still have a gap here for that. We have more plastic sheets, and I'll be cutting more pieces out to fill this piece in. The same process is also repeated at the back. On top of the plastic sheets, we have the solar panels themselves. So 2 solar panels that go at the back. However, we'll have 4 at the front. Now, I'll share with you guys possibly the coolest thing on this car. So, this is the lid of the car, and watch this. Look, it opens on its own. I know I made a rumbling sound at the end. So basically, we installed a little strut in here that keeps this lid up. However, the only disadvantage is that this is too heavy duty for it. It's rated for like 70 pounds, and when you try to pull it down, it's actually like a lot of force. You have to struggle with the strut and push it down and close it. And just to make sure that the lid stays down, I welded these little tabs here, and basically you just slide a pin through here to make sure that the lid doesn't open as you're driving. So since we have a really nice lid for the front, which opens facing forward, we basically had to do something for the back as well. And the back also opens facing backward. The only reason I made it so the front opens facing backwards and the back opens facing backwards as well is that if you step back, this kind of looks like a supercar. That's my only silly reasoning behind it. I just wanted to mimic the characteristics of a supercar where, you know, in an exploded view, it kind of looks cool. Maybe not on a trailer, but sitting outside, it might actually look interesting. The only thing for the back lid I'm missing now is the strut. So I'll be installing this. There we have it. The rear strut is installed. And as you can tell right off the bat, this is way too short. This needs to be longer to allow for a wider range of motion, so the rear hatch or the rear lid also opens the way the front lid opens, just nice and wide. Now the main thing we need to figure out before a test drive is the brakes. What we have connected here is the calipers itself, which squeeze the brake pads, and we have the rotors. But as of now, the wheel can just spin in neutral. So pretty much every vehicle in the world works off of the same principle. You have a master slave cylinder which pushes brake fluid, and the brake fluid then squeezes against the brake pads, and the brake pads like kind of grab onto the rotor, the steel disc we just saw, and that's how a car stops. So there are conditions to this braking setup. The condition is that the brake reservoir needs to sit at the highest spot, and the slave cylinder needs to sit in the middle somewhere, and the lowest spot needs to be the brake calipers. The issue with this car is that once this lid closes, everything is really close together. The brake reservoir will sit right around here. The brake pad, as you can see, is almost at the same level as the master cylinder, and so are the calipers. So that's why it is really tricky. So we'll go on the other side of the car and I'll show you another update. So up here we installed a different brake, basically just welded this tube on the side, and this is an independent braking system for the rear. So that black brake pedal controls the brakes to the front two wheels, and this is its independent braking system for the rear wheel. In case there's a malfunction or something, we have two separate brakes. Let's say if there's a leak in the brake lines or something. So this is a similar concept as well. You squeeze the handle, it pushes brake fluid through the brake line back to the rear caliper. We can actually test this brake because the wheel is in the air. We have a jack stand at the bottom, as you can tell. So if I press the accelerator, you should be able to see the motor moving. Sounds pretty cool. We'll do it again. And then we'll test the brake. So you heard that, the rear brake works, which is pretty cool. Alright guys, so now we're getting to the solar portion of the car, and now we will be testing out the solar panels before we go ahead and install it on the giant lid. So let's go through the process. Now in theory, each one of these 6 solar panels should be making 24 volts each, and as you can see, it's not as bright outside as it was a few hours ago, but right now it's making 21 volts. And when it's super bright, it does go up to 22, 23. That's what it's supposed to do. So the main thing right now is figuring out the polarity. As long as the voltage is positive, the positive is positive and the negative is negative. So with the solar panel flipped over, I have marked the polarity of the panel, and we have wires hanging off to the tabs that we'll be soldering on here. We have the solar panels connected in series, so each of these panels, since it makes 24 volts and we hook it up in series, we add up the voltage together, so we have 24 plus 24 plus 24, so in theory it should be making 72 volts. However, in reality, since we have a cloudy day, we only got up to about 66 volts. And here we have one of the most common charge controllers. The purpose of this controller is to step down and regulate the voltage that comes out of the solar panels, and be able to safely charge this lithium-ion battery. because we produce 72 volts at the solar panel, but the battery is only 60 volts. So the solar panel rating is obviously slightly higher. So we are charging the battery, but at really low amps, at 0.4 amps actually. So I wanted to test it while it's sitting outside before we connect everything onto the car, because that will make it harder to diagnose. So this whole setup is basically a really slow wall charger. Imagine you're charging your phone, you have fast charging option, you have a slow charging option. So imagine this is a really slow DC charger. That's essentially all it is. So this battery pack is actually made up of a lot of tiny little cells combined together, and it has a BMS built inside of it. A BMS is basically a battery management system, and it makes sure that each little cell inside the battery pack charges at the same level, because you can't have one little cell charged at, let's say, 70%, the other cell charging at 60%. So that manages the system, and it already comes with a lead to charge these cells. And what I did is I just bought a bundle of these little connectors, and one of these connectors I just hooked it up here to the solar charge controller. Alright guys, so now we pulled the car outside and the solar panels are completely installed at the front and at the back, and the car is good to go. And now it's the moment of truth. We're gonna try test driving this car and see how it performs. I'm a little bit scared, so we'll just take off this blocker. So first things first, I'm gonna take off this blocker from the back, and yeah, let's roll it backwards. I guess that's all we can do now. Alright guys, to get in the car, the trick that I found out is you hold on to the frame, you stand on the seat. Once you stand on the seat, you stand on the ground just like in Flintstones. Sit, and now you can roll it with your feet a little bit. We don't have a floor now, but we're eventually going to do it. I'm going to hold it with the rear brake. Alright ladies and gentlemen, driving the solar car. This is actually a surreal experience. So I have a little switch here to turn on the solar panels, and if we have enough sunlight, the solar system should be working. It's a little shadowy, but it's pretty cool. It's hard to believe this thing is actually working. It took a lot of work to build this thing. Alright guys, so that is it for the solar car build. Hopefully you guys enjoyed watching the video, and hopefully you got to learn something from it. Please stay tuned and consider subscribing if you enjoy content of this nature, because in the future I'll be coming up with more content of a similar kind. So we'll see you next time. Take care.